Completing the overview of the Sentaurus workbench, now the question arises that how to get the SDE and SDYs command file. So for getting the command file for these tools, first of all you have to open the SDE tool from the terminals. For opening the SDE tool from terminal, you have to press enter, then type SDE and percent and press enter. So this is the interface for SDE tool where you are going to design your device structure, and these scheme commands, when you will design your structure, then corresponding command lines will be generated in this scheme commands section. Then you have to copy these command lines to gedit file. So for opening the gedit file, you have to come in terminal and press enter and type gedit and percent and press enter. So there will be a space, like a doc file will be opened. It is known as gedit, where you are going to paste your command lines from these SDE tools. So let's make simple our PN diode and try to copy these command lines in this gedit tool, right? This is the Sentaurus structure editor where you can design your device structure. So let's see overview of it. Like, the main menu bar contains file, edit, view, draw, mesh, device, contacts. So in this section, draw, you can, like, file section, you can open a model or you can start with a new project. Edit section contains change, you can change the material from your, if let's say you have designed any device and you want to in between change the material, so if from here edit option you can do that. Here more options are like 2D edit tools, 3D tools. Here device operations are available and some parameter things are also in this section. View sections, you can see like light source, camera view, zoom to extend, render, and different topography and grid, show rulers. So this section contains like view sections. Here you can see different perspective of axis, xy, yx, xz, yz, 3D view, right? So these are the thing in view sections. Next is draw sections, where we are getting auto region naming section, exact coordinates, overlap behavior contains merge, new replaces old, old replaces new, new overlaps old. Let's say you are about to design MOSFETs. So MOSFETs contains complex structures, so there maybe you have to use these overlapping behaviors, right? You may need work planes for designing complex structures, right? So draw section contains coordinate systems, 2D create tools. In 2D create tools, it contains polyline, rectangular region, regular polygon, polygon region, ruled regions, like this. 3D create tools contains create cuboid, create cylinder, create sphere, and ellipsoid, right? So it's all about draw section. Now come to mesh. Then in mesh sections you have to define, suppose you have made any device, then you have to do the meshing. So for that you have to define windows, and after defining the window you have to place the refinement placements, like what would be the meshing size, and for that you have to come with refinement placements and do the meshing, right? And different things are also available. So this is not the objective of the course to explain all these tools. So let's move on and come to device. Then device section contains constant profile placements, analytical profile placements, external profile placements, and particle profile placements. It means you can do the like Gaussian dopings, you can do constant dopings, and you can Gaussian doping in the sense analytical profile placements will be occur, like concentration will be vary according to the length of the device, right? And constant profile placements means the doping in the device would be the same in all over the regions. So that's the thing. So it depends what type of doping you want to do in your device. Next thing is contacts. Of course, if you are making any device, then you have to make contacts. So for that you have to came to contact, then contact sets you have to give the name of the contacts and define it, then again you have to set it according to your device, right? So this is the all about SDE SDE tool. So let's begin and design a simple PN diode in this SDE and try to copy these command lines for our Sentaurus workbench tool, right? So for making PN junctions, uh, we need to regions, P region and N regions. So wait. First step to draw the device structure is to select the materials. So for selecting the materials, you have to come here and uh, select the that material by which you want in your that material which material you want to go with, like that. So I want a silicon based PN junction diode, so I will select silicon material. Now next thing is come to draw and turn off the auto region naming. If you are not doing that, it means the software will give a name to itself, the structure, whatever the structure or region you are going to form. So I don't want that I want the name, a specific name to my region. So for that I am going to turn off it. Now next thing is to turn on the exact coordinates, so that the dimensions of the device should be according to my uh, my given points, or you can my coordinate according to my coordinates, not the drag and drop things like that. So I will turn on the exact coordinates. Then after I will came to the 2D create tools and I will select rectangular region, right? Now after doing those things, I will simply drag my mouse and drop, and a pop-up message will come, and it will ask for the coordinates. And let's say you want to form a rectangle in STE, then it will ask for the vertex of that rectangle. It will not ask the length and breadth of the rectangle. So you have to be careful of that. So I will start from my first vertex will be 0 0, and then the diagonal vertex of that for second vertex I have to put. So let's say my first vertex is 0, is like second vertex will be like 0 0.5, 0 0.5 to 1, right? So one thing more, like in SDE all the dimensions are in micrometer. So if I am putting 1, it means the dimension would be 1 micrometer, right? So here I have put 0 0.5, it means it's in x direction it will go from 0 to 0 0.5 micron, means 0 to 500 nanometer, and in y direction it will go from 0 to 100 nanometer, or 1 micron you can say. Sorry, 1 micron, yeah. So I will click OK, then it will ask the name the region. So I will name it like P region, right? So let's make it P region. Okay, P region, and click OK. So a rectangle will form according to my coordinates, given coordinates. So as you can see in the skin command, there are some command lines, right? So these are the commands which should be copied in gedit files. So I will copy it simultaneously, like so. For copying it, you have to select those commands and right click on the selected area. It in this SDE control C doesn't work, so you have to uh, do the like this. Select the command lines, then click right click on that and copy. Okay, then come to gedit file sections and control C will become active in this gedit section, so you can use control B and control C in this file section. Okay, other thing is you have to clean these command lines, like unnecessary things are here, like less than, hashtag, body. These should not be in this file, otherwise we will not be in a position to use this in SWB workbench. So I have to clean this. So for that I will remove these hashtags, body, and less than, greater than symbols, right? So this is the actual commands which will form the P region sections, right? And try to save it. And when you will save, then it will ask the location where you want to save. So let's say I want to make another folder for this, so I will click here and the folder name will be like diode underscore formation trial, I can say, or okay, let's give it a trial. Okay, diode trial, create. Now save it, and it will ask the name for this file. So I will give it same the name diode, or I will give diode. Simply give the name diode only. Okay, save it. Now our gedit file saved by the name diode, right? So come back to our SDE tools and try to complete our device accordingly. So we have made the P regions. Now the task is to make the N regions. So for making the N regions, I will again go to draw tools, or either you can see here there are some shapes of creating rectangular sheet region. So I will just select here, create rectangular sheet, and just drag the mouse. So again it will ask the vertex. So I will put the another vertex for the N region. So it will be like 0.5, 0, and 1, and 1, and click OK and give the region name. So I will give it N region, click OK. So now you can see our PN is formed, like P region and N region with silicon material. The device structure is now formed. Again we have to copy this command line for N region. So I will do the same thing. I will just select and copy and paste it here. And save it. So we have created the device structures. Now next thing is to do the doping. So for doping, we have to came with like we have to go for device, then choose. I want constant profile placements. I want like the concentration in the whole device should be same. That's why I'm selecting constant profile placements. And before that, before creating this, I have to make, okay, let's do it. Constant profile placements and select regions, right? We have two regions, N regions and P regions, right? Suppose there are, our structure is more complex than this one is just the simplest device in VLSI sections. So we have just two regions. If suppose there are multiple of regions, overlapping things are there like CMOS devices, then we have to be specific. We have to do some form window for the specific regions, then do the dopings. Either we have let's say in our case only silicon material is being used. If there are multiple of materials in our device, then we have to take care that the material wise for doping also we can do. So here three options. You can either you can create a window for the whole device and do the mesh doping, or you can go with region or material wise. So I am preferring region wise because we have only two regions and I can do the dopings in those regions. So I just select region, then I will select P region, then I will do constant profile definitions. Then you have to select the species. Like I want the P region should be, so for P region in silicon material case we have to dope it with boron. So we have to select the dopant species boron active concentrations. So for that you have to look here and select boron active concentration. And now we have to provide the concentration of these species, these dopants in our silicon materials. So I just want the concentration should be 1E18. So I will type 1E18, and the concentration in this SDE tools, the unit of this concentration is per centimeter cube, right? So simply click add placements. Okay, so now P region is doped with boron active concentration with 1E18 per centimeter cube. Now select the another material, that is N regions. So N region is being selected, has been selected. Now you have to change the placement name. Like earlier it was constant profile placement underscore 1 only, right? So for the different region you have to change the name, otherwise it will pick the older earlier values. So you have to rename it constant profile placement underscore 2. We have selected region and region. Then you have to change the name of the constant profile definitions also. So let's make it 2. Then you for N regions you have to dope it phosphorus. So you select the species phosphorus here, phosphorus active concentration. Then I want the concentration more than P region, so I will do it 1E18 1E20 instead of 18. And now add placements. So now we have done the doping part, just close it. And our P and N both regions has been doped. Now our task is to copy these command lines in our gedit file. So I will do by just select these commands and copy it and paste it here, and just clear the rest mesh thing. Okay, so we have done the doping part. Next thing is to do set context, making contacts of the device. Just save it. Contacts for this PN diode. So for uh, for knowing that which region is the P and N, so just right click on this selected entity and go to properties. It will tell you that which region is P and which one is which body is P and which one is N. So select this, right click on this body and go to properties, and we will tell this body is N region, right? So for making the contacts, you have to define the contacts and come to contacts, click on contacts, contact sets, then give the name of those contacts. Like I want to do give a name of a node for P region, so I will type a node, and edge color will be 100, edge thickness is 4. Now set. Now again from name the another context, so I will give it cathode, and let's change the edge color, RBG color, make it 101, so that we can see the context in different color, right? Set. Now after defining the contact sets, we have to select the edges where you want to put those contacts. So for that purpose, came to here and select face. I want I want the contact at edge here, so I will select edge. Then you have to click on this cursor, mouse cursor, select, then select the edge. Now it is selected, and come to contacts, then set sorry, not set contacts. Once we will do select edge is now selected, come to contacts, then contact sets, then select the contact, defined contact which you want to put there. So I will select that one is P region, so I want P as a node, so I will select a node and activate it. Now it is activated, just close it and again come to contacts and set contacts. Now you can see the color has been changed, and our contact sets has been done, part has been done. Now let's do the similarly, let's do the cathode part. So I will select the edge, just click on this edge. Now edge is selected. Now you can activate the anode cathode from here also. So just click here and click on cathode. Now it has been activated. Now just come to contact and set contact. Now the our both contacts has been formed, I mean contacts formed. So next target is to copy these command lines in our gedit files. Let's do that. Okay, I think this much. Okay, from till here you have to copy and then paste it here and clean the codes. Okay, this part should be also deleted, so I will delete it. That was just a comment, it should not be in our file. Okay, so in our gedit file sections we have created our structured doping part has been done, and now we have done the contact sets also. Just save it. So next thing is to do the meshing part. Meshing part is remained, so to mesh and define reference window, select rectangle and try to cover the whole region, so that we can do the meshing for the whole device. So this is the thing, just let it be like that and the whole device would be covered. Like we have found the window, so now come to refinement placements. So I will select refinement window, it will select a whole device. Now refinement definitions 1, refinement placements 1. Now what is the maximum element size you want to give it for the meshing? So I just want to 0.1 in x direction and 0.1 in y directions. And what you would be the minimum element size? So I will give it 0.01 in x direction and 0.01 in y, and just create refinement. Now the meshing part for the whole device has been done now, and just close it. And see, we have done the meshing for the whole regions. That is one part. We have to create one another window for the active region, or you can say depletion region, where the current will be the current will be flow, or you can say physics will be solved, right? So we need to take care of that. We have another window for this depletion region. So I will go mesh, define reference window, select rectangle, and select the another window accordingly. Like as you know, the depletion with depends on the concentration of the doping concentration of the materials or region or device, you can say. So in our case, P region concentration is less, and N region concentration is high. So more depletion region will be through the P sides, right? So accordingly you have to choose the reference window and try to refine it. So I have created the another window, and I will go to the refinement placements and select refinement window 2, and try to change the name of the refinement placements name, make it 2, and refinement definitions make it 2 also, and change the maximum element size to 0.12, 0.01 in x, and 0.01 in y, and this min size 0.01 to 0.001 in x, and 0.001 in y, and create refinements and close it. So now we have done the meshing part of this of the device also. Now next task is to copy these command lines in our gedit file. So let's do that. Select and copy. Oh sorry, I think this should be okay. Just try to first copy it. We will look up that and try to clean these things. So we have done the meshing part also. So now we can create control S. Now we can see the what type of doping and meshing we have done in SDE tools. So for that you have to come to mesh, click on mesh and build mesh for visualization purpose. So save grid to file. This it is the SDE model name. It will save by this file will be saved by this name. Just let it be like that and click to build mesh, and it will take some time to create the meshing, and here you go. See, so this is the doping concentration in our PN simple PN junction diode, PN diode. So this is the like boron active concentration you can see, then phosphorus active concentration, and total doping concentration like minus 118 to plus 120, right? So next, this is the doping part. Now let's see the meshing part. So for looking for meshing, we have to just click on mesh, and clearly you can see the meshing in the whole device. The mesh scores, and in the region of active region, I mean depletion region, the mesh is fine, and that is the requirement. Okay, okay, that's it. So successfully we have created our device, and we have copied the command lines from here to gedit file folder. One thing more I would like to highlight here, that these files are going to helpful, like if you want to change your device length, breadth, and anything you want to change your doping concentrations, you want to change the materials, you want to change the mesh size, definement, placement sections. So all those things can be controlled from it. Just edit those values and save it, and just copy all these codes into your SDE command lines, and it will form the device. If you want to show, let's see this. So I will just do the control A and try to copy it, control C, right? And I'm going to just open a start a new file. So for that, model is modified. Do you want to save it? I don't want to save. I have saved my codes in gedit, so I don't want. Just click no. Okay, and this command should be here. Okay, so we have opened the new files. I don't want these commands also from command section, so just I will do control A and delete. Now we have just fresh window in SDE, so I will put my copied commands from this gedit file and just paste it in command section. So control B, and clearly you can see the device has been formed using these command lines, right? So this is the benefits to use these gedit tool to copy it, right? In the last one thing more, in this command line, one command should be also here, that is SDE build mesh. There must be a space in between. Build mesh. Okay, build mesh. Then if I'm not wrong, then it should be like n@node, and it must be in comma form, right? Okay, in this form. Okay, so I think this SDE. Okay, let me check this part in from SWT structure edit commands. Yeah, this one, SDE build mesh and node @. Okay, so same should be here also. Here no any space. Okay, and just save it. Okay, so now this is the command lines for this SDE tools. Okay, so next thing is how to obtain the SDevice command lines. So just 1 second, I will take a break, then I will take this command, these commands in insert in the SWB environments, right? In SWB environment. So for that, I will make a new projects. For that, I will select let's say I am selecting Pradeep. Okay, let's select Pradeep folder. Then I will create a new project, then traditional projects. Error will pop up. I have to click OK. Then I have to source the location. For that, I have to select the location. Let's search for the Pradeep. Here it is. Then double click on it and just click OK. Okay, so a new TMP file will be generated, and try to save it first. Okay, save current project. Then again it will ask the location. So let's say what is the location. So it is 377936. Okay, so this one 377936. Double click on it, and just click OK. Okay, so again just minimize it and again maximize it, so you will able to see the folder name like here. Double click on it, and this is the space where you have to add the SDE tool. So I will just right click on this and add, and come to tools and then select SDE. OK, then batch mode, then apply. OK. Okay, so we are in SWB environment, and I have added the SDE tool. Now the next task is to add the input files in this SDE tool. So just right click on it and edit input commands, and this is the command SDE device command, where we have to input our generated these files, right? So I will just select all these, control A, control C, and try to paste it here, control B, right? Okay, and save it, just save it. Now after adding these device command files, we have to run it. So for running purpose, first we need to process it, so that make sure there must not be any error. So just click on this node and right click on it and pre-process, click on pre-process. So the project has been modified. Do you want, as we have just added the command lines, so of course the project has been modified. Just click yes, and it will process. Just status is okay, processing now 0 means everything is okay with the file, so we can go ahead. Just click on this node, and you can run from here also. Just run selected nodes, click on it, and just okay. So as you can see, observe the colors, it has been changes from ready, pending, then running. Currently it is being run, and now it is done, and the color is yellow, right? So just close it and wait for the edit mode here. When the simulation run, it shows the simulation is running, currently running, like that. So when the running simulation done, then it came to edit mode, so wait for that. Now our STE part has been simulated. Let's visualize it. So for that you have to click on it, right click on it, then come to visualize, then Sentaurus visual. Here, as I have already explained to you, like there must be two files, band.tdr and mesh.tdr. So I will go through, select mesh.tdr file, and okay. Okay, it will take time to visualize. So see, we have doping concentrations, right? And we have our meshing part also in SDE tools, as we have seen separately. So successfully we have created the STE part in SWB environments. Next part is to add the command files for SDevice. So add tools, look for SDevice, okay, then apply and close it. So edit commands, here we go, and we have to input the SDevice command files from here. So how to do that, I will explain in a while.